What's the big deal about sunlight? Well, the mass of our sun is about 2 times 10 to the 30th kilograms. That's more than 99% of the total mass of our solar system. If we could represent our sun with a grapefruit, our Earth would look like a grain of rice. The big deal is 1.3 million of our Earths could fit inside our sun. Our sun is an ideal nuclear power plant located at a safe distance from population centers. Yet, we only use a fraction of the energy it supplies. Photovoltaic panels and windmills and solar collectors are now competitive with the fossil fuel industry. Yet, subsidies and tax cuts for oil companies continue to increase, and the United States is still far behind other countries in the development of renewable resources. Grid-tied and battery backup PV systems will soon replace conventional fossil fuel power plants. Solar heating systems will also become more popular as oil suppliers continue to threaten our ecosystems and violent storms continue to devastate towns and villages. The convenience of energy concentrates like coal and oil and nuclear power will soon become obsolete as we learn how to use intermittent diffuse energies like sunlight and wind. Jumping onto the green energy bandwagon won't be easy. If you have money to burn, you don't need green energy. If you have little or no money, a long-range investment might be difficult. So, you'll have to think big like the sun and start small like a person. Don't give up. A new age of energy independence is about to blossom, in spite of the oil lobbies and energy cartels. It's a simple matter of supply and demand. The demand for energy is increasing, and the supply of oil is decreasing. To get started on the green energy bandwagon, you may decide to build your own collectors to preheat domestic hot water. These serpentine collectors are designed to work together to lighten the load on the pump. Cold water from the storage tank is circulated from the bottom junction to the top junction where it exits as hot water. The temperature and quantity of hot water is determined by the flow rate of the pump, the surface area of the collectors, and the intensity of sunlight. A good flow rate is typically about 0.3 gallons per minute. Solar collectors turn light into heat and transfer this heat into water. Water is an ideal substance for storing and transporting heat. The heated water must be circulated through a storage tank to be useful when sunlight is not available. To automate the process of heat collection, a differential controller is used. Whenever the collector is hotter than the storage tank, the controller turns on a pump and supplies the collector with the coldest water from the tank. A sensor located on the output pipe of the collector compares the hot water return with the cold water source from the bottom of the storage tank. A solar hot water system is not rocket science, and a basic differential controller does not have to be complicated to supply a storage tank with a net heat gain. The differential adjustment involves finding the right balance between heat gain and power conservation. The basic differential controller simplifies this adjustment by integrating the differential on with the differential off. Turning the differential pot clockwise maximizes power conservation. Turning the pot counterclockwise maximizes the heat gain. The best setting is normally midway between these two extremes. Hello again, and welcome to the second part of OurBigSun, called Net Heat Gain. We now understand that our sun is capable of supplying us with all our heating and power requirements directly. The only problem is, our sun is an intermittent resource, and we've grown accustomed to energy on demand. Heat from sunlight is often lost as fast as it's collected, so we need a means of storing that heat when sunlight is not available to achieve net heat gain. Now, to obtain a net heat gain, we could circulate water through a collector and through a storage tank when sunlight is available. To do this, we could turn on a pump every time the collector is heated, but this would be a tedious process. To automate this process, a differential controller may be used. One sensor is placed on the output of the collector to monitor collector temperature, and the other sensor is placed near the output of the heat storage tank to monitor heat storage tank temperature. These two temperatures are compared. When the collector temperature is hotter than the storage temperature, a pump is activated. It's as simple as that. A basic differential controller automates the process of heat collection and storage. A red LED is used to monitor heat availability. The intensity of the red light indicates the quantity of heat that's available. The differential pot is used to balance the heat gain with the power consumption. If very little power is available, the pot may be turned clockwise. If more than enough power is available, the pot may be turned counterclockwise. The best setting is usually midway between these two extremes. Okay, now that we understand how basically everything works, we can do a demonstration to show how the basic differential controller operates. Okay, now we understand the concept of net heat gain from the sun, and we can use a basic differential controller to automate the process of a net heat gain. This is the basic differential controller, and you'll see there's two lights. There's a red light and a green light. When the red light comes on, it indicates a certain amount of heat that's available for collection. The brighter the light, the more heat is available. Once the light gets bright enough, it'll turn on the pump and the green light will come on. Okay, so that's one part of that we need for the net heat gain. It is the differential controller. The most important part, of course, is Mr. Sun. We don't have the sun right here, but we do have a bulb that represents the sun, and right underneath it we have the collector probe. So when we turn that light on, the collector probe should get hot, and if it gets hotter than the storage probe, this is the storage probe, the pump should come on. So here we have the storage tank here, and here we have the pump. We have everything connected. So let's proceed with our laboratory experiment and turn on the sun. Okay, the sun is now on, and you can see the light, the LED is getting brighter, which indicates there's more heat available in the collector than there is in the storage tank. When it gets bright enough, it should trigger the pump to come on. Okay, it's almost there. There we go, and the pump just came on. Now, suppose we want to turn that pump off. Well, if we wait long enough, if we turn the sun off, and we wait long enough, the pump will come off. But what if we don't want to wait? What we can do is heat up the storage probe. I have a soldering iron here. Heat up the storage probe. There. The pump comes off. That's basically the idea of the basic differential controller. Thank you so much for your time. If you need more information, go to jcsolarhomes.com.